particle P rests on a horizontal surface of weight 8 newtons. So I've got 8 newtons coming down, R going up. Horizontal force of 3 newtons, I can put it there. So it's 3 newtons, and P is in limiting equilibrium. Okay, so I'm going to have friction going backwards there. I've got to calculate the coefficient of friction between the surface, and therefore I need F, it's less than equal to mu r, limiting friction, and therefore we've got F equals mu r. So, or mu equals F over r, limiting friction. And so I need to work out what F is, so I need to resolve horizontally, and that means the force that way must equal force that way. And that will say that F equals 3. Now to resolve vertically, and again there's no acceleration here, and so upwards equals down, and so that R equals 8, and therefore mu equals F over R, which equals 3 over 8, which equals 0.375. That's the first bit done. Find the magnitude and direction of the contact force. So the contact force, they like this more now. And the contact force, you can see from my diagram, the R comes from the surface, so that's a contact force, and friction is also a contact force. So what I've got to do is I've got to find out the two parts of the force. I've got R, or F, which goes straight across like so, that's 3 newtons, and R goes up, so I'm going to turn it into a triangle, and that's R is 8 newtons. And I've got to work out that bit there, resultant force. So resultant force, or total contact force, or contact force, and I've got the magnitude is the square root of 3 squared plus 8 squared, and that is 8.544. And the angle equals 10 to the minus 1 of, that's my angle there, of 8 over 3, which equals 69.4439 degrees. Well, it goes on a bit, and that's to the horizontal. I've got a diagram drawn so that hopefully will make it clear. And that's a total contact force. Sometimes it says total contact force, sometimes it says contact force. But if it says direction, then obviously normal contact force goes at right angles, so that's going to be the other bit. It's part 3. Okay, so we've got an angle, a force going up at angle theta here, and it's now, okay, it's still in limiting equilibrium. Given that theta, okay, so start off with theta equals 0, so then draw a picture of that's where we, let's actually get it touching the surface this time. So that's where we are. Force is on here, that is still my 3 newtons. I've still got the weight coming straight down, that's 8 newtons. I've got T going across here, and I've got R going straight up here, and R hasn't changed at all, and therefore friction won't have changed at all, and friction now is obviously not going to go to the left, friction is going to have to go to the right here, and the maximum friction is still going to be 3 newtons, and therefore T equals 6 newtons. That's the first part, A, and now I've got to do the second part, which is B. I'll go back to green, so to blue. Now theta is 30 degrees, so I've got my line going across, I've got my object, I've got my forces on here. Always do the weight first, that's 8 newtons, then I always do normal contact force, that's R. I've still got the 3 newtons to the right, I've got my T, which is coming up here at 30 degrees, and I've got friction, which is going to oppose motion because it's in a limiting equilibrium, and so therefore the friction is going to have to go here. The key part from here is to notice 6 marks. That's we use that to help us think that's quite tricky. So therefore it's going to be more than just copying what we've done here before. And the key thing is now friction is not from 3 newtons because the normal contact force has changed because this part of T is some of that. It's lifting it up. When I break that down into components, I've got that component and that component, and the vertical component here is reducing normal contact force, and therefore friction is going to get less. So I've now got to resolve and resolve left and rights vertically and use limiting friction because it's still in limiting equilibrium. So okay, so I've got to use this formula up here. So I'm going to work out what F is first. So that means I'm going to resolve that way, and that will give me 3 plus F, nothing else going to right, so that will equal T as this part here, which will be T cos 30. Therefore F equals T cos 30 minus 3. Going to resolve vertically, and I'm going to get R plus this component here, which will be T sine 30. Nothing else going upwards, so that will equal 8. So R will equal 8 minus T sine 30. And now I know that mu equals F over R, and I know what mu is because I worked it out earlier. Mu is 0.375. So using F lim equals mu R, that implies that mu 0.375, well, I can do it that way. Actually, I can do F, which is T cos 30 minus 3, equals mu, that's 3/8, it's easier that way, times by R, which is 8 minus T sine 30, and that, multiply this bit out, T cos 30 minus 3 equals 3 minus 3 T sine 30 over 8. Add that to this both sides, and I will get 6 over here. So I'll get T of cos 30 plus 3/8 sine 30, and that will equal 6. I'm just adding that to both sides, and that implies that T equals 5.6951, and that's newtons. And that's question 6 done.